Okay, guys, so we're navigating our way here through our rules of exponents, and next up on the docket here is the quotient property for exponents, and then we got our negative and our zero exponents. So I know it kind of seems like three properties, but they kind of work together. So that's why I kind of put these all in the same lesson. First of all, when we talk about quotient, obviously we're talking about dividing. So we're talking about something like this. Okay, and again, I'm going to start off really, really simple. Let's say we have something like a to the fifth on top of, say, a to the third. If I expanded that out, I'd have a times a times a times a times a on the top. I'd have five factors of a, and on the bottom, I'd have five factors of, or I'm sorry, three factors of a. Okay. Now you should know that when you have something on the top like that and something on the bottom, that they're going to cancel each other out. So that a can wipe out with that a. I got another pair of a's right there I can wipe out. And then I got a third pair of A's right there I can wipe out, leaving me with A times A, which would be A to the second power. So the simplified version of A to the fifth divided by A to the third is A to the second power. So I'm sure you're guessing by now that the rule is to subtract them, right? 5 minus 3 is going to give you a 2. And that is the rule. There's just one little catch. Okay, and here's the catch. I flipped that over. Okay, let's say I went a to the third on top of a to the fifth. Okay, and I just did the same problem just in reverse. That's going to change things. I would have three factors of a now on the top, and I would have five factors of a on the bottom. The canceling, nothing would really change. You'd have a pair there, a pair there, a pair there. What would change is you're still left with a squared. The only difference now is your a squared is on the bottom of the fraction as opposed to being left at the top of the fraction. And when it's on the bottom of the fraction, that means you have an empty top. You can't have a fraction with an empty top. What number do we know that is usually the invisible number? That would be a 1. So number one, you end up with a squared. Number two, you end up with 1 over a squared. So how do you decide where the answer goes? Where does the answer go, on the top or on the bottom? It's really, really easy, guys. Okay. If you look at the original problem, the bigger exponent in number one was the 5, which was on the top of the fraction. The answer ended up being on the top of the fraction. In number two, the bigger exponent was on the bottom of the fraction. Where did the answer end up? On the bottom of the fraction. So my rule of thumb is that you follow the bigger exponent. Okay, you're always going to follow the bigger exponent. If the bigger exponent is on top, that's where the answer goes. The bigger exponent is on the bottom, that's where the answer goes. The bigger exponent dominates. Follow the bigger exponent. Okay, so that's how we're going to attack our quotient property. And you'll see in the examples how we kind of go about this. Now, let's talk about, okay, negative exponents. Negative exponents really, and I'll put this example down here. Okay, again, let's say I had a to the fifth on top of a to the third. I'm using number one over again. Okay, let's just say for some reason you accidentally, instead of doing 5 minus 3, you were to do 3 minus 5. That would give you an a to the negative second on the bottom. Okay. Now, you don't want to do that. We always want our answers to be in positive exponents. Well, we already know the answer to this problem is a squared being on the top. There's really, with number 3, guys, this really isn't a wrong way to do the problem, but I don't want a negative exponent. I want a positive exponent. Well, if we know the answer is this, and we know the answer could potentially be this, wouldn't that make them the same thing? So 1 over a to the negative second is equal to an a to the positive second on the top. The same thing would happen if you did it in reverse, right? A to the third over, okay, a to the fifth. Again, let's say the exact same thing. Let's say you accidentally did 3 minus 5. That would give you an a to the negative second on the top. Well, we already know the answer is an a squared on the bottom. So that would be the same as that. So here's my rule for negative exponents. If you have a negative exponent, just move it, okay? So if you have a negative exponent on the bottom, move it on the top, and that's going to make it a positive. If you have a negative exponent on the top, move it to the bottom, and that's going to make it a positive. It's really that simple, guys. We don't need to overcomplicate this. Now, the last thing we're going to talk about is the zero exponent, and this one's a very, very easy one to explain. If you had a to the fifth divided by a to the fifth, you already know that when you have something on the top and something on the bottom, and those two somethings, for lack of a better way of saying it, are the exact same thing, you know that the answer is 1. If I gave you numbers, right, you would know that 8 divided by 8 is equal to 1. You would know that negative 9 divided by negative 9 is equal to 1. It's no different if you have an algebraic expression. Okay, a to the fifth on top of a to the fifth is going to equal 1. Well, if I examine the quotient property along with that, okay, in numbers 1 and 2, when we were looking at dividing, we said the rule was to subtract the exponents. So wouldn't that be the same thing here? Well, 5 minus 5 would be a to the 0 power. Okay, so what I'm getting at here, guys, is if a to the fifth divided by a to the fifth is equal to 1, and a to the fifth divided by a to the fifth is also equal to a to the 0, don't those two things have to be the same? So my point is, guys, that a to the 0 power is equal to 1. All right, and I use a for a reason. Anything, a for anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. Okay, 9 to the 0 power equal to 1. 38 to the 0 power equal to 1. X to the 0 power, it's equal to 1. Anything to the 0 power is equal to 1. Now, let's apply what we just learned to some examples. Scroll up here. I got some examples mapped out here for you. I look at number 1. What I like to do is I like to draw a fraction bar, and I like to start placing, okay, my numbers and my variables. Okay, so the first thing I'm going to look at is the regular numbers. The regular numbers here are a 3 and a 2. This is a division problem. Okay, so we're going to divide those numbers. The problem is when you do 3 divided by 2, it's going to give me a 1.5. So I'm just going to leave those alone. If it's not dividable, don't divide them. Now I start looking at my letters, right? X to the fourth on top of X to the third. X to the fourth divided by X to the third. Your rule there is to subtract the exponents. 4 minus 3 would give you a 1. So you're left with X to the first power. Where do you put it? You follow the bigger exponent. So X to the first power is going to go on the top. The same exact thing is going to happen with my y's. Y to the fourth on top of y to the third. Okay, 4 minus 3 is 1. Okay, so I end up with y to the first power. That goes on the top. When the exponents are 1, you don't need them. So my final answer to number 1 is 3x over 2. Okay, makes sense? Hopefully it does. Number 2. Again, I like to draw my fraction bar so I can start placing things, look at the numbers, right? You can't do 2 divided by 4 because that would give you 0.5. But you can do 4 divided by 2. 4 divided by 2 is 2. Where do you think the answer is going to go? It's going to go on the bottom. Why does it go on the bottom? Because that's where the bigger number is. You follow the bigger number. 4 divided by 2 is 2. Don't make the mistake of subtracting the big numbers. Big numbers are treated like regular numbers. You divide them. Okay? Now I have a y on the top, which is a y to the first, and I have a y to the second on the bottom. So that's going to be a dividing problem. My rule for dividing is to subtract. 2 minus 1 gives me 1. So I'm going to end up with a y to the first power, and it goes on the bottom because that's where the bigger y is. The bigger exponent with the y is on the bottom. I have an x to the second, and I have an x to the fourth. 4 minus 2 is 2, so I'm going to have x squared. The bigger exponent is on the bottom, so that's where I'm going to put the x squared. If you notice, I ended up with an empty top. Anytime you have an empty top, we talked about this in the examples earlier, you have to put a 1. Okay, so my final answer is 1 over 2yx squared. Okay, you could also make that 1 over 2 x squared y. If you want to go alphabetical order, it doesn't really matter. These are both the same thing. Okay, hopefully you guys are following this. Obviously, you can always come back to it. Okay, number 3. Okay, get a little more complicated on you. Now, the big numbers, you can go about the big numbers a couple different ways. Okay, I got a 2 on the top, I got a 2 on the bottom, I got a 4. 2 times 4, you know, would be 8. 8 divided by 2 would be 4. That's one way you could attack it. Or you can think about it this way. I think this is the easier way. Wouldn't this 2 and this 2 take themselves out, leaving you with a 4? Okay, so you can cancel them out. Okay, that would probably be the easier way to go. Okay, now start looking at your variables. See if there's anything you can cancel out. In this problem, I don't think there is. Okay, so let's take a look at the x's first. You have an x to the second on the top. You have an x to the fourth on the bottom. That would be a 4 minus 2 situation, right? 4 minus 2 is 2, so you're going to end up with x squared, and it goes on the bottom. Follow the bigger exponent, so I'm done with my x's. I look at my y's. The only y in the problem is this y to the fourth right here. So that's going to stay where it is. And then the z's you can attack a couple different ways. Okay, this z and this z, that's our product of powers rule. So they're going to get added. So the z to the third and the z to the fourth, they're going to make z to the seventh. And then that z to the seventh is on top of the z squared. So those are going to get subtracted, leaving you with z to the fifth. And then you follow the bigger exponent. So the z to the fifth is on the top. Okay, so your final answer is 4y to the fourth, z to the fifth over x squared. Okay. Number 4. Okay, I got a lot more action going. Now I threw some negative exponents in there. Okay, first thing you should do, look for things you can cancel. I can wipe that 4 out with that 4, leaving me with this 4 on the bottom. Okay, now see if there's anything else that can cancel. I don't think that there is. Okay, when you're looking for things to cancel, you're looking for things on the top and the bottom that are exactly the same. They're identical. I don't think I have that here. I don't. So what you're going to do is you're going to start shifting the negative exponents. You're going to leave the positive exponents where they are, and you're going to move the negative exponents to the top or the bottom, depending on where they're at. So stay along with me here. Okay, the m, that's going to stay. Okay, because that doesn't have a negative exponent. That's going to stay. The p to the negative second, I'm going to put that on the bottom, make it p to the positive second. Okay, to make negative exponents positive, we move them. The q to the fourth is going to stay. That's not moving. On the bottom, I have an m to the negative third. I'm going to move that to the top and make it m to the positive third. The q to the third is staying. The m to the negative second gets shifted to the top, makes m to the positive second. The p to the fourth stays, and the q to the negative second goes to the top and becomes q to the positive second. Okay, the 4 is going to stay on the bottom. Now let's look at my variables. I got an m, which would be an m to the first. I got an m to the third. I got an m to the second. That's your product of powers rule. This is an m to the first. So with those 3, I would add their exponents. 1 and 3 make 4, 4 and 2 make 6. So on the top, I got m to the 6th. So I'm done with my m's. Okay, let's go on to the q's. Okay, the q's, I got q to the 4th, q to the 2nd, q to the 3rd. The 2 on the top, okay, add to make q to the 6th. Divide that, subtract the 6 and the 3, gives you a q to the 3rd. You follow the bigger exponent, you leave that on top. So I'm done with my q's. The p's on the bottom, I got a p to the 2nd and a p to the 4th. There's your product of powers. They add to make p to the 6th. Okay. And your final answer there is m to the 6th, q to the 3rd over 4p to the 6th. I know that this seems like a lot, guys. All right. But if you take your time and you go nice and slow, these rules are not hard. Okay. Again, the same thing we've been saying all along in this chapter. X's with X's, Y's with Y's, A's with A's, B's with B's. Okay. Treat the big numbers like the big numbers. If it's a multiplication problem, multiply them. If it's a division problem, divide them. Okay. We're going to ease into this. I'm not going to rush you. Okay. Feel free to keep going back to this tutorial and back to this video if you need help. Okay. Good luck, guys.